Today's math routine is Convince Me That, and there's some links for you on slide 5. There are hundreds of pre-made Convince Me That, so less work for you, more learning for the kids. And then the last 40 minutes, we work on a rich mathematical task. So let's jump right into the math block here. This is Convince Me That. And what's going to happen is everyone's going to start off with their very own slide. You'll notice there are lots and lots of slides below. And when you type your name in the yellow box, you're kind of reserving that as yours. So slide 8, for example, Lisa has reserved that. So go ahead and find a slide, put your name on it. Oh, Raha, I'm so excited to hear that your kids are obsessed with this. This is awesome. Um, and you're going to use the manipulatives. There's even a number line at the bottom. You can use a text box. You can use whatever you want to convince me that 5 divided by 1/2 is greater than 5. Whenever you want more ideas, check out other people's slides. It is not cheating in this class to check other people's slides. It's inferring what they're thinking. And you can even drag those little emojis or copy those emojis over to their thinking to show that you have a connection with them. Mary, to get to the slides, you'll click this link here. And currently slide 12 is available. Let's see, there's more. Slide 21 is available, 22, 23, and 24, and 25. And down in the 30s, there's more. If you're just joining us, welcome. We are already into our math routine. Here's the link to the Google Slides, and you're finding yourself an available slide in the teens and 20s, and you're going to convince me that 5 divided by 1/2 is greater than 5. At this point, if you have an idea on your page, take a moment and look at some of the others. And if you find that you're, gosh, still thinking about that, you're not quite sure, it's a great place to put the still thinking emoji. You can just drag it over. If you love their way, show them with the I love this emoji. One thing that I like to do in online learning is allow students to be the owner of their learning. So at this point, we're going to have several things happening. You might still be working on your own slide where you're creating your own representation, and that's fine. You can continue. You might be browsing others through an emoji gallery walk, and that's fine. You can continue. Or you might be on the same slide as us. I'm going to call on a couple people. You might choose to look at their slide, and they're going to fill up the airspace with talking. That's going to continue to get our thinking rolling. And I'd love to start off with Naomi. Um, it's on slide 6. And can you tell me how you thought about this problem?
So I was saying that when I take 5, what I'm doing is I'm looking for how many halves there are in 5. And what I found that there were 10 halves in the 5. So therefore, thinking about that, if I think about the 10 separate from the halves, 10 is greater than 5. Or when you divide 5 divided by a half, you get a 10, and 10 is greater than 5.
I love the way you said that. There's 10 halves in 5. Um, and there's definitely some numbers that I see in your model. I see the number 5, there's 5 circles. I see 10, there's 10 semicircles. I see 1/2 with it cut, but I also see the number 2. I see 2 pieces in a hole.
Yeah, because I was thinking that, when you think about how many halves are in a number, it's going to always be double that number. When it's, whole number is easy to think about it.
So
And if it was thirds, it would be triple the number. If it was fifths, it would be 5 times that.
So Naomi, that's actually going to be the topic of today. I'm going to put that in the chat box for us to think about. When thinking about a half, it is double. And I want to keep coming back to that, and it's a really cool connection. I'd also like to check out Cathy's on slide 9. Cathy, would you tell us a little bit about your thinking? Because I don't see any circles on your slide.
Yeah, I like that
one. Yes, I work with upper grades, and so we work a lot on number lines. And so the way I worked with it was to see what is the distance in halves. So I just grouped them by halves to show that there would be 10 jumps that were the distance of 1/2 between 0 and 5.
I can definitely see that connection. Very cool. Gail had a really cool problem that she wrote on slide 13. Gail, can you tell us how you thought about this?
I was thinking about, taking a walk, and halfway we've gone 5 miles. That halfway point in the 5 miles would mean that the whole trail would be 10 miles long.
Interesting. I love the way we look at things through an area model and then these distance models. If I were to continue this math routine, obviously I could spend all day taking these apart, but I do want to keep the math routine short. And so I want to leave this little nugget of slightly wonderment, slightly making new connections, and then we would come back tomorrow and we would compare Gail and Kathy's model and what they might look like. And then we'd even bring in some more. So just by doing this one routine, I actually now have a week's worth of routines to do because every day we can come back to it and bring up somebody else's model and use that to convince me. So all you need to do is make one slide and you have the materials for a whole week for doing Convince Me That. All right, let's jump down to our math task for today. Before I do, on slide 33, if you're interested in the protocol that I used for this, some people want to know, like, what are the steps? I made sure I assigned everyone a slide. They had the opportunity to move things around, to comment with emojis, and to share out loud.